Okay, one thing we can use the absolute value for is distance on a number line. Okay. And by this definition is essentially going to help us with that group of problems, because it tells us that the distance between A and B on any number line is just A minus B, and then take the absolute value. Okay, the reason we use the absolute value is because then it doesn't really matter whether A or B is bigger than one another. Okay? Because if we had two numbers on the number line, say -3 and 5, if we did -3 minus 5, subtracted those, okay, we of course get -8, which is not a valid distance because a distance is always positive. Okay, however, if we take the absolute value and take the result and get 8, okay, then that does describe how far apart -3 and 5 are on the number line. Okay, another way we could do it is we could actually draw the number line and count. If we counted our way from -3 to 5, we'd find out that it's how far apart? It's 8. Okay. All right. If we had done it the other way, if we did 5 minus -3, then we would have gotten a positive 8, which ultimately is still 8. Okay. So when we're looking for the distance between any 2 points, and like I said, that's part of the directions for that 49 through 52. Okay. When we're looking for the distance between any 2 points, we can write it just like this. So if I wanted the distance between, let's say, x and v, okay, what kind of expression am I going to write here if I want the distance between x and v? I want to do x minus v in absolute values. Because then, ultimately, it doesn't matter whether x is bigger or v is bigger, because that will give me a distance, won't it? Okay? Right. So that's what those problems are talking about in there. So we're going to use that to handle those problems in a few minutes. Okay? Other thing to note, and again, this is pretty much what I talked about. It doesn't really matter which way we subtract them, because whether we get a positive or a negative answer, we're going to take the absolute value and we'll get the same thing regardless. Okay? Now, we also know, though, that in math we don't always deal with just a one-dimensional system like a number line. Okay? A lot of our work is done on a coordinate plane, okay? And we want to find distance on a coordinate plane. We have a complicated-looking formula to deal with. Okay? So, where does this formula come from is what we're going to look at first, and how do we use it. So, first of all, if I were to take the points 1, 1, so 1, 1, and we'll say that this is 4, 3, and I want to find the distance between those two. If I was on the coordinate plane and they were horizontal or vertical to each other, then I could just count, just like it's a number line. Okay? But if they're on some kind of diagonal to each other, okay, counting is not an option. Okay? But you'll notice the way that I drew this picture, if I want to know how far it is from this point to this point, if I were to make a right triangle out of this, I would have an x component and a y component. And if I do make a right triangle, okay, based on what we learned in algebra and geometry and algebra 2, okay, we could use the Pythagorean theorem, couldn't we? Okay? So one might ask, the first question is, man, that formula looks complicated. Do I have to memorize it? No. Okay. Don't have to memorize it, because at minimum, couldn't you just draw a picture and use the Pythagorean theorem to find the distance? Absolutely. Okay. But ultimately, this particular equation, it really is the Pythagorean theorem. It's just in a bit of a disguise at this point. Because ultimately, if we took our triangle that I drew, and I wrote x squared plus y squared equals z squared, that would be true for the way I have it labeled. Okay. But that x right there, look what that x is. All that is the x coordinate of this point minus the x coordinate of this point. Okay. To get that distance right there, wouldn't I go 4 minus 1 to get that distance? And that's exactly what we're doing in general here. We're doing 4 minus 1 here. Or we could do 1 minus 4. It really doesn't matter the order, because when we square something, it's going to become positive. So it really doesn't matter what order you subtract in. And then that y component I have right here, okay, isn't that, in this case, 3 minus 1? The subtraction of the two y coordinates? Okay. And so if I did that, and I put them in there, this would be, for me, my x squared and my y squared. And that would all equal d squared, but if I want to get d itself, what am I going to have to do to both sides? Take the square root. Okay. So there you have it. All that formula really is, it's just the Pythagorean theorem in disguise, isn't it? Okay. So like I said, do you have to memorize that? No, you hopefully already have the Pythagorean theorem memorized, so you don't have to have that particular formula memorized to be able to figure out the distance. Okay. I do want to point out a couple things when using the distance formula. First of all, on my example, I'm going to use -3, 4, -2, -5. And when I use the distance formula, I have on my first step, I did -3 minus -2. Notice I made those plus plus because it's minus a negative. 4 minus -5, also plus plus. And if I do the subtractions, which both turned into additions in this case, I get the following. And I'm going to show you common mistake number one for people on this is that they say that -1 squared is -1, which it's not. Okay, anytime we square something, it's going to become what? Positive. So if in this line, if you write something negative, it's never going to be right, is it? Okay, square something, it becomes positive, always. Okay. And then finally, we can add those two together, we get the square root of 82, and that will be our answer for the distance between these 2 points. Now, a couple things to note about this, this class, a couple of ways that we're going to proceed together. Number one, unless it tells you to give the distance to some decimal point, it tells you to do that, then you can take your calculator and punch it in there. But if it doesn't, then you should just leave this as the answer. Okay? This is the exact answer. If you put this in your calculator, you're going to have some rounded answer. Okay? So unless it tells you to round it, okay, leave it like this. Okay? There's one other part to radicals that we learned about too that we need to make sure we do, and that's if we have something that is simplifiable, if you will, okay, we need to do that. And remember that there's a couple different techniques that we can use, but bottom line is we need to know, can this be broken down at all? Do any of these perfect squares go into 82? So 1 does, of course, but that doesn't do any good. But if I try 4, okay, that's not a whole number. 9, no. 16, no. 25, no. 36, no. None of them do. So in this case, we're done. 82 is as good as it gets. Okay, had we gotten 32, though, and if we left it like that, okay, we'd lose a half point because the radical 32 needs to be simplified. Okay, what number can go into 32 on this list? 4 can, but there's a better one. Yeah, 16 can. I always want to find the biggest perfect square that'll go into that, and then break that up into, instead of 32, 16 times 2, and then that radical 16 becomes whole number 4. Okay, and this is a good time to mention that skills like this, like simplifying radicals, I'm assuming that you can do that already, okay, based on the fact that you passed algebra and algebra 2. Okay, if that's not the case, okay, you need to let me know that. Okay, because if this is something that you can't just do, then we need to get that fixed. Okay, so at some point, come let me know. I need help simplifying radicals, because what I can do is I can print out worksheets that have a bunch of these on there that you can practice and work on with me, so that when it comes time to do this, that you can just do it. Okay, but like I said, by being in this class, I'm assuming you know it. Okay, but if that's not true, you need to let me know that. Okay, we can fix whatever you need to get fixed, but you need to let me know what you need help with. Fair enough? Okay, good. Okay, any questions on dealing with the distance formula? All right, well, the next part then is we're going to look at midpoints. Okay. So when we have 2 points on a number line, like say 6 and 14, if we wanted to find the midpoint between those two, okay, all we do is use the formula. But again, instead of memorizing the formula, just think about what that really is. If I add 2 things and divide by 2, what is that? Okay. So just what simple word would we tell our parents that that is? Okay. What is this? If you took 2 quizzes and you got an 18 on one and a 20 on the other, okay, what might we do? Figure out the what? Yes, it's just the average. Okay? All that is the average. So instead of memorizing the formula, couldn't you just think, oh, if I want midpoint, I just need the average? Okay? So at this point, if I told you to find the average of 2 things, I'm pretty sure that we could all do that. So if you know that, then there's no reason to have to memorize a separate formula, because all that is the average. So if we did that in this case, of course, we do 6 plus 14 divided by 2, we get 10. And as we did in the distance formula, we'll translate this to, instead of 1 space, we'll translate it to 2 space. Okay? 1 dimension. Okay? Now 2 dimensions. And what it boils down to is if we have a segment on the coordinate plane in a 2-dimensional situation, like the point 1, 1 and the 4, 3 like we did earlier, if we want to find the midpoint between those two, okay, then we need to find ultimately A and C are the x's. So simple terms for this would be the average of the x coordinates. True? And then the second coordinate would be the average of the y coordinates. Okay. So again, can you memorize this with the A, B, C, D and all that? Sure, you can if you want to, but do you need to? No. All it is the average of the x values, average of the y values. So in my case, I did 1 plus 4 divided by 2, 1 plus 3 divided by 2, and that gave me my midpoint, which is 5/2, 2. Okay. All right, one other procedure issue I want to discuss here at this point for this class, and this is going to be our rule for the entire class, and for the next, if you continue to take calculus here. When we have something like 5/2, okay, do not type that into your calculator and tell me the answer is 2.5. Okay? There's really no good reason to change that to a decimal unless it tells you to do so. Okay? Leave stuff in fraction form. Okay? And one thing that I'd like you to try to do throughout the course of this year to help you for next year, okay, is try not to use the calculator unless you have to. Okay? So like I said, there's really no good reason to make that 2.5, so don't do it. Okay? Just leave it as 5/2. Notice that I'm even letting you leave it improper. If you want to make it 2.5, that's fine. Okay? But you don't have to. Okay? 5/2 is fine. Okay, unless it tells you to do that, okay, then just leave it just as 5/2. Okay, it'll save you some time too. I know a lot of people are in the habit of, as soon as you see some fraction, you got to type it in your calculator. Don't do that anymore. Okay, leave it as a fraction. Okay. All right, and finally, our last part today, we're going to look at the equation of a circle. Okay. Ultimately, the equation of a circle also comes from the Pythagorean theorem. We're going to spend some time here shortly dealing with equations of lines and equations of parabolas and equations of other curves that we've studied. Okay, but in this section we're just looking at circles right now. Keep in mind that the general form here, if you do have it in the general form, you can read the h and the k, which is the center coordinates, right off the equation. Okay, and you can also read the radius right off the equation. So if I were to say x minus 5, I'm going to say x plus 5 instead. X plus 5 and y minus 3 equals, let's say, 144. Okay. So if you have that equation that is in the form of a circle, then you should be able to tell me some information about that circle. And if you know the information, you can also graph it. Okay. So first of all, identifying h and k here, what is my center point for this? If this is a plus 5 here, and the general form is minus, then what must I have plugged in to make that turn into a plus? Yeah, it had to have been a negative. So the center would be at -5. And again, minus, this is still minus, so that k must be a 3. So -5, 3 would be our center point we'd identify. And then what about the radius? We've got to be careful on this one because a lot of people say, oh, the radius is 144. Okay, it's 12 because this item on the right is r squared, not r. So this would be our 12 square root of 144. And of course, like the last one, if that were to have been a 32, then we wouldn't put radical 32 here. We'd put 4 radical 2. We'd have to break that down if it's able to be done so. Okay. Questions so far about the circle equation? All right. And lastly, I have another example. I've given you the center and the radius, and then we wrote the equation. You notice that when we have a positive coordinate, okay, it's x minus, okay, just like the general form. And this became a plus because it was minus a negative. Okay, and then of course we don't put 4 here, we put 4 squared, which is 16. So part of our work we're going to be writing some equations for circles just like we did here. One thing that I also would expect here at this point is that if we do have a minus situation, that we don't leave it like that. Okay, we're all good enough mathematicians that we shouldn't leave it looking like that. Okay, if you have a minus, change it to a plus, please. Okay. All right, that is it. Give me a second.